Your ancestors never met a pure substance. There is a plant growing on the eastern slopes of the Andes that people have been chewing for about 8,000 years. The leaf is unremarkable. Slightly bitter, a little green, the texture of a bay leaf. You tuck a wad of it into your cheek with a pinch of ash or powdered lime, and over the next hour or two, a mild alertness spreads through you. Your hunger softens. The altitude stops pressing on your chest quite so hard. You can work. Now take that same leaf and run it through 19th century industrial chemistry. Strip away the fiber, the water, the dozens of other compounds until what's left is a white crystalline powder containing, by weight, somewhere between 50 and 100 times the concentration of the active alkaloid that was in the leaf. Same molecule, same receptors, same brain, completely different event. And that gap between the leaf and the powder is one of the most important and least understood facts about the human body. Because your nervous system is old, not old like your grandparents, old like the Cambrian. The receptors that respond to these compounds have been sitting in animal brains for hundreds of millions of years, and for every single one of those years, they lived in a world where nothing arrived pure and nothing arrived fast. Then, in the space of about 200 years, we changed both. Today, I want to talk about the single variable that matters most in how a substance affects a body, and it is not the substance. It's the delivery. It's how concentrated it is and how fast it gets to the brain. Your ancient hardware has excellent tolerances for one of those worlds and essentially no tolerances for the other. And once you see that, a lot of confusing things stop being confusing. Let's start with the world your hardware was built for. Imagine you are a primate 12 million years ago on the floor of an African forest. You are not a hunter. You are, for the most part, a very anxious salad eater who occasionally finds fruit. And here is the thing about fruit on a forest floor. It is almost always slightly rotten. It has fallen, it has split, and wild yeasts have gotten into the sugars and started converting them to ethanol. This is a problem because ethanol is a poison. It is, biochemically speaking, a solvent. But it is also a problem you cannot avoid because the alternative is to not eat the fruit, and not eating the fruit means you die. So evolution did what evolution does. Around 10 million years ago, in the ancestor shared by humans, chimpanzees, and gorillas, a gene called ADH4 picked up a single amino acid substitution. One letter changed, and that one change made the enzyme it codes for roughly 40 times better at metabolizing ethanol. 40 times. From one letter, that is the patch. That is the entire reason you can drink at all. Your liver's capacity for alcohol is not a human achievement. It is a fruit scavenging adaptation that predates your species by about 10 million years, and it was tuned, precisely, expensively tuned, for the concentration of ethanol you get in fruit that has been sitting on the ground for a few days, which is somewhere around 1%, maybe 2% if it's been a warm week. A glass of wine is 12%, a shot of whiskey is 40%. You are running a fruit processing enzyme at 20 to 40 times the load it was specified for. And the interesting part is not that this causes problems. The interesting part is that it works at all. That is how much headroom that one mutation bought us. We are still coasting on it, but notice what the ancestral environment could not do. It could not concentrate. A rotting fig cannot become whiskey on its own. Distillation requires a still, and a still requires metallurgy, and metallurgy is a few thousand years old at the outside. For 10 million years, the ceiling on alcohol exposure was set by yeast, and yeast has a hard limit. It poisons itself and dies at around 15%. The universe had a built-in dose cap. We removed the cap. Now hold that thought and go back to the coca leaf because the same story runs there with different numbers. An Andean farmer chewing leaves is absorbing the alkaloid through the lining of the cheek. It seeps. It takes 20–30 minutes to build. Blood levels rise like a hill, sit at a plateau, and come down over hours. The curve is gentle, and the leaf, importantly, is not just the alkaloid. It's a whole matrix of other compounds, fiber, alkaloids, that partially counteract each other, and the physical bottleneck of your own cheek, which can only absorb so fast. Purified and concentrated, the curve is not a hill. It is a cliff face. Seconds to peak instead of half an hour. And your brain does not measure concentration. Your brain measures rate of change. That's the thing I want to land on, because it's the piece almost everyone misses. The reward circuitry in your midbrain, the dopamine system running through the ventral tegmental area and into the nucleus accumbens, is not a pleasure meter. It is a prediction error detector. It exists to notice when the world just got better than expected, and how suddenly. It fires on surprise. It fires on slope. Which is a superb design if you are a small mammal in a forest, because in a forest, the size of the surprise is genuinely useful information. Ripe fruit after 3 days of nothing. Water after a dry stretch. A sudden steep signal meant something real had changed, and you should update your behavior immediately and remember exactly where you were standing. That machinery is doing exactly its job when a purified compound hits. It is reading a slope steeper than anything in the natural world and concluding, correctly by its own logic, that the most important event in your life just happened and everything else should be reprioritized around it. The circuit isn't broken. The circuit is being lied to by a stimulus it has no vocabulary for. Let me give you the timeline, because the compression is genuinely startling. Opium, the dried latex of the poppy, goes back at least 6,000 years. Sumerians wrote about it. It's a mix of dozens of alkaloids taken by mouth or by smoke, and it is not gentle, but it has a natural ceiling. Morphine gets isolated in 1804. One compound pulled out of the mixture by a 21-year-old German pharmacist's apprentice named Sertiner. That is the beginning of the whole modern era. The moment we learned you could take a plant and extract just the part that acts. The hypodermic syringe arrives in the 1850s. Now you can bypass the gut entirely. No absorption delay, no first pass through the liver, no ceiling set by how much your stomach can stand. Heroin, a modification of morphine that crosses into the brain faster, is marketed by Bayer in 1898 as a cough medicine for children. And fentanyl, synthesized in 1960, roughly 100 times more potent than morphine by weight, means the difference between a dose and an overdose is now measured in units your senses cannot detect. You cannot see it. You cannot taste it. There is no evolved warning system for a milligram, because for 10 million years, nothing in the environment ever mattered at a milligram. 200 years. From poppy latex to a compound where the margin is invisible. Your receptors are 600 million years old. Opioid-like signaling systems exist in animals with no backbone. That machinery predates fish. The mismatch isn't close. It isn't even the same order of magnitude of time. And once you frame it as a delivery problem rather than a substance problem, the confusing cases stop being confusing. Why is coffee, a drug unambiguously, a plant pesticide that acts on your adenosine receptors, something we hand out in offices with no concern at all? Partly because caffeine is mild, but mostly because of the delivery. It's dissolved in a large volume of hot liquid you can only drink so fast. It goes through your gut. It peaks at 45 minutes. Hill, not cliff. The same molecule, concentrated into pure powder, has killed people, and it killed them not because caffeine became more dangerous, but because the mug was gone. Why is nicotine from a patch a smoking cessation therapy and nicotine from a cigarette one of the most reliably habit-forming things ever mass-produced? Same molecule. The patch delivers a flat line over hours. The cigarette delivers a spike to the brain in about 10 seconds because the lungs are an enormous absorptive surface with a direct route to the heart. The tobacco industry understood the slope decades before the public did. That's what the engineering was for. And why did chewing coca leaves for 8,000 years not produce a public health emergency in the Andes, while the purified compound did in cities that had it for less than a century? Not because Andean people are different, because a cheek is a bottleneck and purified powder is not. There's one more piece of ancient hardware in this story, and it's the one purification defeats most completely. Your body has an entire warning system for exactly this problem, and it's older than your species by an enormous margin. Bitterness, for a start. You have somewhere around 25 different bitter taste receptors, and they exist for essentially one reason. Plant alkaloids are bitter, and bitter historically meant toxic. That's a chemical alarm sitting on your tongue. Behind it is the nausea reflex, and behind that is vomiting, a violent, expensive, whole-body ejection mechanism whose entire purpose is to get a poison out of you before it finishes absorbing. And running underneath all of it is the simple physical fact that your stomach has a volume and your gut has a rate. That is a layered defense. Detection at the mouth, rejection at the stomach, throttling at the intestine. It is not a bad system. For 10 million years, it was very close to sufficient. Now notice what every step of purification does to it. Concentration means the effective dose is small enough that the bitter signal never crosses threshold. Any route that isn't the mouth, inhalation, injection, absorption through a membrane, skips the taste receptors entirely and the vomiting reflex along with them. And speed means that by the time the nausea does arrive, the compound has already crossed into the brain. The alarm still works perfectly. It just goes off after the event it was supposed to prevent. We didn't disable the safety system. We built a delivery route that goes around it. So here's where this leaves us. And I want to be careful, because it would be easy to hear this as a story with a comfortable moral. It isn't one. The point is not that natural things are safe. Plenty of plants will simply kill you, and plenty of traditional preparations are genuinely dangerous. Nature is not a safety system. Nature is just slow, and slowness happened to impose limits that functioned like a safety system by accident. The point is that your body is a very good machine solving a problem that no longer exists. It evolved sophisticated, layered defenses against a world where the dose was capped by yeast, absorption was capped by a tissue, and speed was capped by digestion. Every one of those caps was real. Every one of those caps has been removed, not by evolution, which needs millions of years, but by chemistry, which needs an afternoon. And that gap is not going to close. There is no version of the next few centuries where your ancient midbrain circuitry catches up to industrial chemistry. 10 million years brought us one amino acid substitution, so the only thing that can close it is the part of you that can hold both facts at once, that the machinery is doing precisely what it was built to do, and that what it was built for is gone. Your ancestors met the leaf, you meet the powder, same receptors, same brain. Nothing else the same at all.